You're listening to Carbon Removal Newsroom, a weekly show about current events in the world of carbon removal, from technology and innovation to policymaking and job growth. Brought to you by Nori, the carbon removal marketplace.
Well, hello everybody, and welcome to our first episode of 2023. Hard to believe that we've flipped into the new year. Today, we're going to be talking about the science of carbon removal, and I am joined, as always, by Jane Zelikova, who's the Executive Director of the Soil Carbon Solutions Center and Joint Faculty in Crop and Soil Science at Colorado State University. Hello, Jane. How are you doing?
I'm great. Welcome to 2023.
Yeah, hard to believe. And also joined by Shannon Valley, a paleoceanography and marine biogeochemistry researcher who has served on Joe Biden's NASA transition team and is currently a AAAS Science and Technology Policy Fellow at USAID. Hello, Shannon.
Hello, good to be back.
Yeah, nice to have you back. And as always, I'm Radhika Mulgafkar, Head of Supply and Methodology at Nori. So today we're going to dive a little bit into enhanced rock weathering, or ERW. Last month, the nonprofit Carbon Drawdown Initiative published a blog post featuring pictures of 11 projects across the world where researchers were spreading basaltic rock dust onto farm fields. This technique is known as enhanced weathering, and the post shows an upward trend in popularity. According to the blog, the projects photographed cumulatively spread 50,000 tons of rock dust onto farm fields last year, with another 500,000 planned for this year. These pilot projects are conducted by a growing number of organizations that believe vast amounts of carbon dioxide can be sequestered from the atmosphere by applying basaltic rock dust to working croplands, with the added benefit of also improving agricultural yields. If it works, it represents an affordable carbon removal method with significant co-benefits. But as always, the devil is in the details. And so today we're going to look a little bit about if and how scientists can tell that carbon dioxide has been drawn down, and what techniques and experiments we need to do to confirm that the process is really doing what we think it's been doing. So we'll start with an Oxford study, which was released in December when a group of researchers published the results of their 14-month trial in which basaltic rock dust was spread over soil cores for 13 months. Unfortunately, the study found limited carbon dioxide removal compared to the models. So Jane, if you don't mind, could you give us kind of an overview about this study and kind of what it found?
Yeah, happy to. This is a new study that's adding to a growing body of scientific work, still pretty limited, but more and more studies coming out all the time that's looking at the effects of enhanced rock weathering, specifically in soil systems. And so this particular study looked at the rate of dissolution of basalt minerals, so specifically basalt rocks, in the lab using 1 meter deep soil cores that were collected from croplands in the UK. And they used an application rate that is similar to a recent study published in 2022 that was basically 100 tons of rock dust per hectare. The application rate is pretty high. And the study is essentially what I would call a soil column study, where the soil cores were collected in the field and kept intact as much as possible in these kind of plastic sleeves, transported to a field, from the field into the lab, and then set up in a way that exposes only the tops of the soil column to the local weather. And the tops are 10 centimeters in diameter, so pretty small. And so they use basalt as the rock because it doesn't have high levels of what is potentially toxic nickel and chromium that can be found in other rocks like olivine. And it can also be better for agricultural soils if these end up being applied in agricultural contexts. Basalt has been assessed in the lab before, and there are some other studies coming out, including one that I reviewed recently. But not a lot has been done in conditions that are similar to what you might find in the field. So this was, as close as they could do to a field trial by keeping the soil cores intact, but certainly is still a pretty controlled, essentially lab study.
Thanks, Jane. That was really helpful for a non-scientist, because when I read the study, I was a little lost. I'm not going to lie. Shannon, curious just from your perspective, obviously study design plays a huge role in how experiment is brought forth, and the results sometimes it can even be influenced by it. So when you are thinking about these studies, what are some of the factors that you consider when trying to measure alterations to living systems like the soil? I know you are more focused on the ocean, but I would imagine some of it is analogous.
Yeah, I'm familiar with at least one kind of study I viewed that was involved with doing some olivine placements. So kind of a similar type of thing, but in the field. And one of the challenges that our team was looking at was trying to make sure, on one hand, in the field study, you have study plots that are kind of far apart enough so that your control materials or your study materials weren't kind of impacting each other. So like if you have some kind of rock material that's being placed in one area, these are labile things that move around, right? So making sure that your control is actually separate from the study areas. But at the same time, you want them to be kind of proximate enough that you have similar enough environmental conditions. So that's just kind of one thing. But my main kind of thing that I'm thinking about is, in the real world, stuff is moving around all the time. And, like controlling for different types of terrain, different types of hydrology, how water is moving through the system. Those are all kinds of things, even animals and burrowing things that can be in different ecosystems, kind of understanding like how you're measuring for that and how you're kind of controlling for that, particularly in a field study, is challenging, which makes sense then why this study decided to not do it in situ, but to actually remove the cores and then kind of study that back at the lab.
Yeah, I'm curious from both of your perspectives, the impacts of movement, as you said, Shannon, in the various ways. How do you control, or can that be controlled for in any sort of experimental study? And if not, how do you then extrapolate to kind of real world conditions in if you're unable to control for that? So I love both of your opinions. Jane, I'll start with you and then move on to Shannon.
Yeah, I think controlling for the movement of water through soil is really challenging. There are ways to do it. They're pretty they can cause a lot of disturbance. You can certainly sort of collar the area that is your experimental site, dig down and put in like sheets that prevent lateral water flow. And do it with enough buffer around your experimental plots to where hopefully that doesn't create artificial water pooling or fundamentally change the way the water would ordinarily move through the system. But it is really challenging to control for water flow below ground. So, there isn't like an ideal solution here. Yeah, I mean, I think that's this is always going to be just a really big challenge when you're working in natural systems, especially soil systems. So one thing that you could do is like overcome the variation with enough replication. But that is also challenging because these experiments, like what they set up, it was a pretty intensive experiment with a lot of measurements being taken, some of them pretty expensive. So the replication here is just 3 cores, which is really not enough of a replication at all. And that's probably my biggest issue with the studies is the lack of replication. So yeah, because soils are so variable in space, you have to replicate your plots. If you're going to be doing this as a field experiment, you need to have a lot of replication to overcome the natural variation that you see, which, the issue Shannon brought up with having enough space between control plots and experimental plots to make sure that your, rock dust that you're applying, which it is dust that does move in the air, doesn't sort of like, ruin your control plots, like that is also an issue. So lots of considerations here, but it is easier to control particle flow in the air than it is to think about water flow in the soil you can put up barriers above ground, maybe easier than it is to put barriers in below ground.
Which actually kind of dovetails into the next question I have for you, Jane, which is one of the critiques of this study was that measuring dry, unirrigated soil was bound to find low weathering rates. Can you maybe discuss briefly how important the role of water flow is for carbon drawdown via enhanced weathering, and if you see this as a fundamental flaw in the study?
Yeah, I actually didn't think that this was the fundamental flaw. I think it's really important to test the efficacy of this approach, especially in systems that don't receive a lot of rainfall or aren't irrigated. We need to understand the application of, rocks in a variety of systems, and we need to have sort of boundaries from the driest sites to the wettest sites, so we can have the full distribution of effect size, and we can then model the process and the mechanisms a lot better if we have these kind of boundaries. So I don't have an issue with them doing the study in a relatively dry environment or in an environment where the rates of weathering are low because it's non-irrigated or doesn't receive a lot of rainfall, or maybe is limited by temperature. So I think the fact that they found a much lower weathering rate is also not surprising given the lack of water in the system. So it sort of feels like the criticism doesn't make any sense to me. Like the whole point of the experiment was to test it in a drier system, and yes, the rates are lower. It doesn't necessarily mean that the rates that have been used or modeled are artificially high, as long as it doesn't the model does represent the variation. The variation is what's important here. So I don't find this to be the critical flaw. I think it's just a necessary study in order to set the lower range or limit for enhanced weathering potential rates, and helps us kind of bound the estimates of the overall impact.
So Shannon, I'm curious from your perspective, if what you thought of the study design and if it impacted, or the study itself impacted your thoughts on enhanced rock weathering, and led you to draw any conclusions about its efficacy.
Yeah, I mean, coming as a non-soil scientist, kind of being a little bit on the outside of this, I actually thought the design was rather clever. The study design was supposed to get at this kind of happy medium, kind of not oversimplifying things as you would in the lab, but also not getting into some of those complications that we discussed previously about what a field study would do. So kind of meeting this middle ground of taking the cores, but then and kind of leaving them intact, but then putting them on top of the roof of their actual earth science building, and irrigating them and seeing kind of what elements are coming out of that. So I thought it was a pretty clever design. The only question I had was I was a little bit curious as to, and maybe Jane, you could say more about this, as to like why they didn't also, there was like a big lag of time between when the cores were actually extracted and then when for the study materials, or for the study cores, when the basalt was added, and then for the controls for all of the cores, I guess, when the irrigation was started and when they started taking the measurements. I was curious as to why they didn't then just like kind of remove a core right before the water sampling started, to just kind of see how different kind of the more recent field extracted soil was from the sediment that had been kind of sitting on that roof for many, many months. But maybe there's something else going on with the further studies, because they noted there was a lot more cores that were extracted that they haven't discussed in this study. But yeah, in terms of like what I've drawn away from this, I think to Jane's point, it's an interesting kind of perspective of kind of one end member of this kind of relatively drier environment, and a relatively cooler climate as well. They're in Oxford, England. So, but there's, as the authors note, there's a number of factors that contribute to weathering rates. So it's not only the water flow issue, but also temperature, soil acidity, the types of minerals you use, of course, the sizes of the particles that are applied, the types of plants that are in an area that can mediate some of the weathering process. So there's a lot of variability there. And also because weathering is usually enhanced the wetter and the warmer your climate is, you usually hear about this being best applied in the tropics. So again, I haven't reviewed the whole literature as to what studies have been done thus far, but I would like to see other studies kind of looking at some of those other variables that influence the rates of weathering and seeing what that other kind of end member state would look like if you were to apply this in, say, a tropical, really warm, year-round, kind of really wet area. What does that rate look like if you did the same type of experiment?
Yeah, really good points, Shannon, and totally good call. So they collected 36 cores and they only used 6 in this study, which means they're using the other cores for other studies, which they hinted at, especially like hinting at looking at other types of rocks in addition besides basalt. The reason they let them sit for so long, and this was also an important and clever aspect of the study, is like when you remove a soil core, you're causing a lot of disturbance and you need time for things to settle back down. So for example, when we do soil respiration studies in the field, we install these PVC pipe looking cores into the soil, and then we have to wait a few days before we go back to do the measurements because we cause a lot of disturbance, including changing sort of the gas, how the gases move through the soil, just by installing or causing pressure on certain points of the soil. So that's why they had it sitting. I mean, 8 months maybe felt like too long, but there must have been a reason. Maybe there was a seasonal issue. They needed to kind of go into the spring, and that's why it was 8 months. But yeah,
maybe they were waiting for a grad student to be available.
Maybe they needed a grant to be available to go and measure stuff. That is probably what happened.
Oh, I love to hear about the practicalities and realities of science and academics, things I have no idea about. So I want to pivot a little bit now to the application of enhanced rock weathering within the carbon marketplaces, because at the end of last year, Puro.Earth, one of the largest vendors of carbon removal credits, added a framework to certify ERW credits to be sold on their platform. Previously, ERW-based credits have never been available on large scale in the carbon markets. And even Puro acknowledges general scientific consensus on best practice does not quite yet exist. But they're going ahead and trying to take a stab at getting ERW funded through carbon credits. So Shannon, curious, what do you think of Puro's framework for certifying enhanced rock weathering?
Yeah, I think that the framework seems pretty comprehensive in terms of what they're asking for. Although you already kind of introduced the caveat, which is that the science so far is not very mature. So they're asking for what information we would like to have in order to go forward and mature this practice, but we're not there yet. So it's like holding folks to a standard that that still has to be kind of proven out. But I think that the kind of principles that they put forth, of course, the ones that you see across all types of CDR, in terms of asking for evidence of additionality, no double counting, quantification of the actual mitigation, about the actual drawdown, that they say will be improved over time. So as we gain more information and folks are able to kind of reduce the error bars and the uncertainty around how much any kind of given application of ERW could actually be, how much drawdown that could actually lead to, then that they're expecting that will be refined over time. They have a lot of good information that they're asking for in terms of kind of environmental impacts. I think we're going to talk about a little bit more later. Whether I think there's enough kind of guidance there, I think that can kind of be disputed. But I think that's an important piece. They also require folks who are applying for this within this framework to actually follow kind of environmental safeguards that are put forth by either the local regulations or by different EU thresholds, whichever is more robust. And if it's less robust than the EU thresholds, then they, require some kind of explanation of that. So I think they're really trying to be comprehensive in terms of the kind of scientific and technical robustness, but then also some of the environmental and kind of social governance issues as well. But like I said, there's probably more to be fleshed out, particularly on the ESG side. But overall, I think they're hitting the kind of top points in a good way.
So Jane, obviously we were just discussing like how many questions, scientific questions, are still unresolved for this type of technique. Did you feel like how Puro Earth approached it did a good enough job to acknowledge those questions and to safeguard against maybe over accrediting?
I think acknowledge, yes, safeguard, no. I mean, a lot of this is really jumping way ahead of what we know in terms of the science. And so there must be incredible pressure to develop a methodology and start crediting, because companies are being stood up around this sort of approach. I'm not going to call it technology. And whether we like it or not, companies are trying to buy these credits, whether a methodology that we think is robust and verifiable exists or not. Like, people want to buy these credits. And so there's pressure to sort of put something in place and just caveat the hell out of it. And I think when I read this methodology, it like reads like a lot of a sort of scientific analysis, like we don't know this and we don't know that. And that's great to be upfront about all the things we don't know. And yet this methodology exists. So it sort of contradicts itself. There are a lot of challenges in predicting these kinds of reactions in the soil environment, which we already have a really hard time, as we've talked about time and time again on this podcast. Soils are tricksy. There's a lot of variation, and it's really hard to predict how carbon is going to be transformed in soil systems. So it's really hard to have a confidence in the estimates of drawdown, be they simulated using models or measured in the field. Our field methods for sort of measuring inorganic carbon transformation are limited. We don't have really good in situ methodology. The models that sort of predict enhanced weathering in different systems is also limited. We have some fundamental equations. We know that eventually this carbon ends up in the ocean, but there are, forward and backward reactions that sort of off-gas carbon along the way. So we have to be really good at predicting what happens over really long periods of time and sort of large spatial extent. We just aren't really good at that. So I think it's great that a methodology requires performed monitoring over the weathering time, but if we don't even know what the weathering time is, how long do we know how well do we know how long we should be monitoring? For me, I think it's really good the methodology is upfront about everything we don't know and all the sort of issues that exist in this space, and yet they have a methodology for issuing credits. And I'm always going to be troubled by that.
I'm going to move on to my next question, because what you said, Jane, there's so much there more I'd love to talk about, but we don't have the time today, maybe in the future. So Shannon, I think one of the goals of a lot of people who work in the carbon removal credit space is that somehow getting more funding for projects like this will help close these knowledge gaps. So do you think that that is viable and a potential positive outcome for creating a ERW methodology at this time frame?
Possibly, but I have some questions. And sorry to jump back to the previous point, just to touch on what Jane was saying about crediting despite not having full information, particularly about kind of the full time frame. I point out also that the framework wants to basically pay out or do the crediting once it's been determined that there has been some drawdown. But again, if we don't have the time frame well constrained, then that becomes kind of a challenge too. So yeah, funding up front and not having all of the answers, that seems tricky to me. The other questions, I guess, related to that I have though, are just, it always goes back to, if you're crediting, what are folks paying for if we don't have it well constrained? Are we kind of harming or kind of skewing the market by pricing removal in a way that doesn't reflect the reality of kind of the carbon dioxide removal itself? Kind of how do these credits compare to crediting for more mature CDR techniques? That's one of the questions that I have. Even if you are trying to reach those knowledge gaps through that, what does that mean? Is this kind of framework or this kind of market, how does that compare to others? And how do you help people kind of understand the differences between the robustness of different credit types across the CDR marketplace? And then the other question I always have is then, like, how are these knowledge gaps being addressed? Kind of who is in this community of practice, who in the scientific community is being tapped to review and evaluate the outcomes of these projects? As these kind of burgeoning fields and these kind of sub practices and kind of sub sectors of CDR are growing, I worry about the same people kind of being tapped for the same things over and over, and are we getting enough input kind of across the research community, from early career researchers, more experienced researchers, non-academics? Where are these kind of inputs put from, and is there enough transparency around that? I did note that one of the key principles of this framework itself is transparency, so I'm all about that if that happens, but obviously knowing who's involved, making sure that a diverse knowledge base is being tapped to kind of answer these questions and are involved in these projects is really, really important at this early stage.
Yeah, I love the sort of call for transparency and where possible, like posting code, etc. And I also like, you can, as reading the methodology, you can tell folks that are working specifically in this space on the science had a lot of sort of a heavy hand in crafting the methodology, but those people weren't named. So great call for methodology, but if you're not going to name the people that wrote this, like, that's step one of transparency. Just
Amen.
saying the working group doesn't quite give me enough confidence that the working group is representing the diversity of knowledge that we would need. So yeah, step one of transparency kind of failed.
Interesting point, Jane. It didn't even cross my mind, but that's a really good observation. So last question for you both, and we've kind of touched on it briefly, but would love to get your thoughts on Section 5 of the framework, the environmental and social safeguards. We've talked many times on this program about the importance of both having community buy-in, but also meeting community where they're at, and kind of wondering whether you thought this went far enough, too far, not enough. What were your thoughts on this section? I'll start with you, Jane, and end with Shannon.
Yeah, I think Shannon probably has really good thoughts on this, so I'll be brief. I like that there's so much emphasis on environmental and social safeguards, and the idea that the activities don't cause significant harm, with no definition of significant. But I will say, like, the local regulations around toxic elements vary regionally, vary in different countries, and especially in the tropics where the potential for enhanced weathering is probably highest. Probably the enforcement of laws around toxic metals and application of things to soil are probably the most lax. And so even if there are laws on the books, they might not really be enforced. And so where we're going to likely see the biggest potential for scaling this approach is also probably areas where the regulations are not very robust, and the methodology does default to local regulation. So I guess I'm a little bit worried, like, it's really great in words, but I think in practice, it's not going to be robust. That's just my thought.
Shannon?
Yeah, I think One thing I like is I like that the guidance for projects goes beyond simply asking for no harm, but also encourages pursuing co-benefits. I think those co-benefits could probably be actually spelled out in more detail here. Again, this not being my area of research, I had to look around and try to understand for myself. And knowing that, some of this, one of the co-benefits could be, for example, supplementing micronutrients in agriculture for crop growth. But I think sometimes folks don't realize that people who are interested in kind of exploring this space and funding in this space, they do actually use these documents kind of sometimes not as supplementary, but as kind of almost a first step. So really, I think that these types of things, if you want folks to get engaged, also because of the co-benefits, and you want to encourage that, then you really should spell that out a little bit more. And similarly, I think just that they kind of cite principles of localization and justice, but there's no kind of additional guidance or standards or criteria for accomplishing this. So they want folks to kind of projects that are engaging in these activities to reference that. But I think kind of having some type of baseline of reference, again, as kind of US EPA or EU standards for toxicity are very explicitly pointed out here. If you're going to say, environmental and social governance issues are important as well, then those kinds of guidelines should actually be spelled out and not kind of just left in for people to, as Jane was saying, kind of do a lot of hand waving and talking about it, but not actually being specific and really deliberate about it as well. We really need to move on kind of beyond some of those top line talking points. I think lastly, one thing I would like to maybe have seen spelled out a little bit better is not just the issues of concern around environmental harm that could be from heavy metal releases or kind of asbestos type things in the sediment and going into groundwater or affecting crops, but also kind of what those interactions may be in crop systems where you also may have applications of pesticides or kind of other treatments that happen in cropland. And what does that mean if you're introducing weathering materials, and then that's mixing with these other kind of agricultural materials as well. So kind of speaking specifically to testing and monitoring for those types of systemic interactions in the field and in practice is something I'd like to look out for as well. But great that this was considered and great that that's put into the framework to start.
All right. Well, thank you, Jane and Shannon, both for that great overview of ERW and also the methodology. Last little bit today is the good news. And the good news is something that is, I think, pretty cool. And that is that mangrove loss has slowed down significantly. And that's so important because both mangroves are both a big sink of carbon dioxide removal and also so important for shoreline habitat and ongoing health. And so the best thing about this article, which we will drop into the show notes, is it talks about some local communities, Costa Rica and in Mexico, that are sort of figuring out how to manage their ecosystems in a way that's beneficial for the local communities while also being beneficial for the environment. So we'll link to that in the show notes, but I encourage everybody to read it because it's kind of nice to hear of a success story in environmental restoration. With that, I thank you, Shannon and Jane, both.
Yeah, thanks so much. This was great. Great start to the new year.
Thanks so much for listening to Carbon Removal Newsroom. If you like the show, the best way you can help us is by giving us a great rating and review in Apple Podcasts, following the show on Spotify, and by sharing the show on social media. Tell your friends and help us spread the word about what's happening in the world of carbon removal.